Hello. I'm not sure how many people we've got here at the moment, but we'll just hold on for a few seconds. I do like to start on time because obviously those who do turn up at the beginning shouldn't have to hang around waiting for everybody else to turn up. But we'll give it another 30 seconds or so. Okay then, so welcome to How Ready Are You to Start A-Level Maths? So this is aimed at anybody who is about to move on to start the A-Level course, probably having just done the GCSE, but it may be that you did your GCSE ages ago and you're going back to education and straight into the A-Level after quite a gap. So if you're intending to start A-Level Maths this September, regardless of where you've come from, if you want to be certain that you're making the right choice, that A-Level is the best choice for you, and that you want to know how to make sure that you're ready to hit the ground running when you start that course. Because if you take the whole summer off, you're probably going to find that it hits you pretty hard. Oh, I should... Okay. Oh, I should check. Can you all hear me? Could you please, somebody please put something in chat just so I know that you can hear me. Anybody? You should be able to click probably at the bottom of the screen. Oh, great. Someone can hear me. So I hope that means everybody can. Thank you, Kishan. Okay, a little bit about myself. My name's Lynn Davis. I'm a qualified teacher. That's what QTS stands for, qualified teacher status. I've been teaching GCSE and A-Level Maths for 16, 17 years, 2004. I've got experience in several sixth form colleges and schools in my local area of Birmingham, Solihull. As well as teaching, for the last few years, I have been marking exams for one of the major boards. In fact, I've also marked for one of the other boards in the past as well, but only one exam series. Most of my marking has been for a single board, for AQA actually. I left most of my classroom teaching at the end of 2016, and since then I've been focusing mainly on private tuition, although I still have had the occasional day back in the classroom doing a bit of cover work. I have two websites. I've got one at b28mathstutor.co.uk, which is my sort of shop window site, if you like. And that looks like this. So b28mathstutor.co.uk. And I also have a site at mathscourses.co.uk, where I've got a selection of courses that you might like to have a look at. So back to the PowerPoint. So the first thing I wanted to talk about is whether A-Level Maths is the right choice for you. Firstly, do you either have or expect to get at least a grade 7 at GCSE? If you don't, if it's a grade 6, you've got a bit of an uphill struggle, because there is an awful lot of algebra and trigonometry at GCSE, and that tends to be the grade 7 plus content in, at A-Level. That tends to be the grade 7 plus content in GCSE. So if you don't have those underlying algebra and trig skills, particularly algebra, you're really going to struggle with A-Level. If you love algebra, graphs, trigonometry, all the problem solving kind of stuff, then A-Level is going to be ideal for you. You're really going to enjoy it. But on the other hand, if you like to avoid algebra as far as you can, but you like statistics, then A-Level probably isn't the best choice for you, because it is very, very heavy on algebra. So maybe you could consider, if the institution that you're going to offers A-level statistics, that would be a good choice for you. And also psychology, biology, business, economics, they all contain a lot of statistics work as well. So you could do A-level statistics and one of those if they're on offer. And finally, if you really love maths and you want to do twice as much as a normal A-level, there's also the option of doing further maths. Now, most places will only let you do that as a fourth A-level, and they might let you in with a grade 7, but generally they will want a grade 8 for that. So we've talked a bit about A-level maths and a quick mention of further maths, but there's also core maths that's worth considering if you're maybe not quite up at that grade 7 or not quite so confident on the algebra. So core maths is equivalent to an AS level. So in terms of UCAS points, when you're doing your university applications, that's worth 40% of an A level. And it's all about applying your maths skills to real world situations, real world contexts. Most of the content is higher GCSE maths level. There's a little bit that's beyond that, but not very much of it, only about 20% of it. The names and the specifications, so core maths is actually an umbrella term used to describe a lot of different qualifications, but they're all equivalent to 40% of an A level. They're all level 3 certificates. So for example, the AQA one is called the Certificate in Mathematical Studies, the level 3 certificate in Mathematical Studies. I think that's the most popular one, but I don't really know. Then the Edexcel one is the Pearson Edexcel level 3 certificate in Mathematics in Context. The City and Guilds version is the level 3 certificate in Using and Applying Mathematics. There's an NCFE level 3 certificate in Mathematics for Everyday Life, and so on. There are lots of others as well. So since it's higher GCSE content for most of it, it's accessible to anybody who has got at least a grade 5 at higher GCSE. And if you did foundation and got a grade 5, it's still doable, but bear in mind you will have a lot more new content to get to grips with, because it does go right up to the top of GCSE maths, the higher tier and beyond. If you're interested in finding out a bit more about the different options that are available on post GCSE for doing maths, have a look at these two sites. I will paste them into the chat in just a moment. I have got them open already. How to choose your sixth form subject. So this is a blog article of my own. And if you're in the chat window, you should be able to see that now. So you can click on that and maybe put it aside, bookmark it for later. And also the AMSP, the Advanced Maths Support Programme, has this quite extensive article that's well worth a read. So amsp.org.uk, so /students/GCSE/what next with a hyphen in the middle. So yeah, you might like to click on those in the chat box, open them up in tabs in your browser and go back and have a look at them later. Anyway, back to the PowerPoint. So let's assume you've already thought all this through and you know that A level is the one you want to do. So what do you need to do now? Well, if you've spoken to anybody who's done this course before, you're going to know it's pretty intense right from day one, right from the beginning. And if you take the whole of the summer off, or you think, oh, I've got a grade 7 in my GCSE, I'll be okay, you're going to find that it'll probably hit you quite hard. And you don't want to be this person struggling here, do you? But if you do some work over the summer and make sure that you're up to speed on the skills you're going to need, you're going to make your life a lot easier. I mean, imagine struggling over this terrain, putting your ankle out every few steps. And you can see that somebody has laid the groundwork here and made the route much, much easier. So this is what you're going to do for yourself if you put some work in over the summer. So what GCSE skills do you need for A-level maths? Well, most of it is what we call pure maths. That accounts for 2/3 of the A-level. And the bulk of that is algebra. So everything you've ever done in algebra, you will need for the A-level. And also all the work on graphs, which is basically just algebra in pictures. The graphs and algebra are very much intertwined at A-level. All the work you've done on trigonometry will come into it as well. And all of that is underpinned by fraction arithmetic, which sounds like basic primary school stuff, doesn't it? But you'll be doing a lot of work with algebraic fractions and with calculations with fractions when you're doing calculus, integration and differentiation, which if you did IGCSE, you'll have had a little bit of experience of differentiation, but for GCSE, it's not in there at all. It's completely new at A-level. So you really need to be comfortable working with fractions, manipulating fractions. Then we've got surds and indices as well. You need to have a good understanding of those to underpin all the work you do at A-level. Vectors, actually, you do get a few pure vectors questions, but they're not really any harder than what you get at GCSE. More what you see for vectors is that they're used as context or used to give a shape to mechanics questions more often. So that's the pure maths stuff that you're going to need for A-level. And then we've got the applied maths. Oh, also your formulae, they will assume that you know those. Things like surface area and volume of a cylinder might come up. And you'll be expected to remember that from GCSE. They won't give you the formula. So going on to the applied maths, we've got statistics, which is all the data handling stuff that you've done at GCSE. And also everything you've done on probability. And then we've got mechanics. And that's all the travel graphs, so distance time graphs, speed time graphs, or displacement and velocity time graphs as well. And the work that you've done in science as well, whether you've done, if you've done 3 separate GCSEs, you'll have done it in physics. If you've done combined science, you'll have done it as part of that. You'll have talked about forces and drawing force diagrams and about Newton's laws, and that comes into A-level maths as well. So the statistics and the mechanics are each about 1/6 of the A-level. And then the other 2/3 of the whole thing is all the pure maths. And vectors tends to be lumped in with the mechanics, though it can vary between boards. So now let's have a look at indices. And I'm going to give you a lesson now to help you make sure that you're up to speed on all the stuff you need to know about indices, ready for the A-level. So starting with the basics of indices then. So you should know, obviously you will know what a square number and a cube number are. And you should know all the square numbers up to 15 squared and all the cube numbers up to 5 cubed. So of course those are all your square numbers up to 12 squared, you know from your times tables anyway, don't you? 13 squared, 169, 14 squared, 196. So if you can remember one of those, you can remember the other. And 15 squared is fairly easy to work out anyway. And then you've got your cube numbers. 1 times 1 times 1 is 1. 4 times 4 times 4 is 64. 5 times 5 times 5 is 125. If you know beyond that, brilliant, but it's not necessarily expected. Now, what's the difference between this and this? Take a moment to compose your answer. And I would like you to type it into the chat box, but don't press send yet. And when you put things into the chat box, you've actually got 2 choices. Because if you look at the chat box, you can see that it says, just above where it says type your message here, it says to, and it defaults to everyone. So if you leave it on everyone, then what you paste in there will appear to everybody who's on this call. But if you pull down the drop-down menu, you can choose only to send your message to me, and then it won't be shown to everybody. So if you're not too confident about your answer and you'd rather that only I saw it and not everybody else did, you can just put it in to me rather than to everybody. Okay, so if you've got an answer and you've typed it in, press send. And let's see what you've got. Okay. Yes. Yeah, there are brackets in the second one, but what's the significance of those brackets? Well, the first one, what you're saying is this is 3 squared with a minus sign in front of it. So 3 squared gives you 9, and then we're making that 9 negative. So we're doing 3 times 3 and then putting a minus sign in front. Whereas with this one, we are squaring that whole negative 3. So it's negative 3 times negative 3, and that one gives you positive 9. And you mustn't get those mixed up because you'll throw away an awful lot of marks if you do. So if you raise a negative number to a power, you should always put it in brackets. Now, if the power is odd, it doesn't actually make a difference to the answer. Because, no, sorry, yeah, if the power is odd, if your number is odd, then your number raised to the power will also be, let me put that, start that again. If the power is odd and you don't miss out the brackets, you're still going to get the right answer anyway, because you're still going to get a negative answer. But if the power is even and you miss out the brackets, you'll get the wrong answer. So if you have a negative number raised to a power, always put it in brackets. Okay, moving on then. There are 2 numbers that you can square to get 25. What are they? Type them into the chat box and let me know. And just press send when you're ready to go. I think most people have just sent directly to me, so that's fine. What numbers can you square to get 25? Yes, you can square 5, but you can also square negative 5 and get 25, can't you? So you have to remember, if x squared is 25, then x isn't just 5. It could be negative 5 as well. So any square number always has 2 possible roots, not just 1. You've got to remember to consider them both. Okay, a few more questions for you to have a go at. Work out the values of these. Type them into the chat box. I've put don't send until I say, but if you're sending direct to me, it doesn't really matter because the other people aren't going to see it anyway. The idea of the don't send until I say is so that it will, you're not going to give your answers to other people who are still working theirs out. So yeah, type them in and send them whenever you're ready. Okay, yeah, mostly right so far. Okay, yep, the first one then is 2 written out 5 times with times in between. So you're not really timesing 2 by itself 5 times, you're timesing 2 by itself 4 times. So you've got 5 2s altogether, multiplied together, which gives you 2 2s are 4, times 2 gives you 8, times 2 gives you 16, times 2 gives you 32. So everyone who's given me an answer got that one right. And then we've got 3 to the 4 is 3 times 3 times 3 times 3. That's 9. Times 3 is 27. Times 3 is 81. So most of you got that right. You could also think of it as 3 times 3 is 9, 3 times 3 is 9, so 9 times 9 is 81. And then, of course, 10 cubed, 10 to the power 3, is 10 times 10 times 10, which is 1000. What about if you're asked to square a fraction? How would you do that? Well, you would, if we're squaring the whole of a over b, that's the same as a over b times a over b, isn't it? And a over b times a over b is the same as a times a on the top and b times b on the bottom, because that's how you multiply fractions, isn't it? You multiply the numerators, you multiply the denominators. So we get a squared over b squared. So what you're doing is you're squaring both the numerator and the denominator. So here are a couple for you, or a few for you to have a go at. Again, put your answers in the chat box. Just use a / for the dividing line. You will still get fractions. Give you a minute to work them out. Okay, a couple of mixed answers, some right, some wrong. Well spotted, spotted your own mistake there. I'll give you a few more seconds and then we'll go through them. That's right, common mistake. One person has spotted that they times by 2 instead of squaring. 3 squared is not 3 times 2, is it? It's 2 3s multiplied together, so it's 3 times 3. So yeah, first one is 3 times 3 on the top, 5 times 5 on the bottom. So that gives you 9 over 25. Next one is 4 cubed on the top, 3 cubed on the bottom. Well, we know that 4 cubed is 64 and 3 cubed is 27, so it is 64 over 27. And then the third one, very similar, 5 cubed on the top is 125, 2 cubed on the bottom is 8, so it's 125 over 8. If the original fraction is improper, top heavy, then the power of that fraction will be top heavy as well, as long as the power is positive. We'll get onto that on the next slide. Now, we're going to look at the laws of indices, and we're going to look at negative indices. So I would like you, on your paper, to write each of these out in full and then simplify it. So I'm not just looking for a number, I'm looking for a 2 to the power something as your answer. Okay, when you've done each of them, you can put them into the chat box. And you can either use the little hat symbol that's above the 6 on a keyboard, at least on a British keyboard, to show a power. Or if you're on a Windows computer, you might not know this. I only found it out quite recently. If you press the Windows key and the full stop button, it brings up a character map like this. You see that? And if you go into the Omega section and click on the Infinity tab at the bottom, you've got lots of superscript symbols here and fractions and all sorts of mathematical stuff that you can use, as well as having emoji and other useful stuff. So you can use those to put your powers in if you like. Okay. Yeah, some good answers coming through. Take a little bit longer. So the advantage of having these lessons pre-recorded, which this one obviously isn't, is that I can just say, pause the video, work out your answers, press play when you're ready to go through them. And then if you're struggling to keep up, you can take your time doing it. If you're really quick, you don't need to wait for everyone else to catch up, do you? Okay, let's have a look at the answers then. So for the first one, we've got 2 times 2 times 2 times 2 times 2. So we've got 5 2's multiplied together. That's 2 to the power 5, isn't it? For the second one, if you write a divide as a fraction like this, that's all a divide sign is. It means a fraction. This dot is this number here, and this dot is this number here. So we've got 2 times 2 times 2 times 2 times 2 on the top, 2 times 2 on the bottom, and we can divide by 2 top and bottom, can't we? And again. Now, when you divide by 2, it doesn't just disappear, it's replaced by a 1, because what we're saying is 2 divided by 2 is 1, 2 divided by 2 is 1, and the same again. So we've got 2 times 2 times 2 times 1 times 1, and just 1 times 1 on the bottom. So that gives us 2 to the power 3, because the 1's don't change anything, do they, if you're multiplying? Then for C, we've got 2 squared, so that's 2 times 2. And we've got that 3 times multiplied together. So that gives us 2 to the power 6. And for D, very similar, except we've got the 2 3's multiplied together. So 2 times 2 times 2 times another 3 2's multiplied together. So again, that's 2 to the power 6. So looking at those, you can work out what the laws of indices are. The first law of indices, if you multiply the two numbers together, like on A, what did we do with 2 and 3 to get 5? We added the powers, didn't we? So if you're multiplying the terms together, then you add the powers. They've got to have the same base, though. So it's got to be the same number that you're raising to the power, otherwise you can't combine them at all. The second law, going the other way, we had a power of 5 and a power of 2, and we ended up with a power of 3. How do you get from 5 and 2 to 3? You subtract, don't you? So if you're dividing, then you subtract the powers. And for the third one, when we've got a power of a power, we've got 2 and 3 gave us 6, 3 and 2 also gave us 6. So we're multiplying the powers, aren't we? So that's the 3 laws of indices that you need to know and be able to use. Okay, now some for you to have a go at. And I would like you to, again, write them out in full, like we did with these ones here, and see what you get for an answer doing it that way. And as well as doing that, I want you to apply the second law to those calculations, because they're all divide ones, so they're all second law questions. And see if you can come up with any conclusions from that. So I'll just give you a minute or two to think about it. You can put your answers in if you like. But I'll just give you a minute or two, and then I will go through the answers to that. Yeah, a couple of good conclusions for the first one coming through. Okay, for the first one then, we've got 2 times 2 times 2 on the top, 2 times 2 times 2 on the bottom. What do you get when you divide a number by the same number? You get 1, don't you? We can cancel by 2 top and bottom 3 times, And we end up with 1 times 1 times 1 on the top and 1 times 1 times 1 on the bottom. So of course the answer is just 1. For the second one, similar, but we've got an extra 2 on the bottom. So of course we're left with just 1 on the top and 1 times 2 on the bottom, which is a half, isn't it? And for the third one, similar again, but we've only got 2 2's that we can cancel. So we're left with 3 lots of 2 multiplied together on the bottom. So that is 1 over 2 cubed, which of course you could write as 1/8. Now looking at the second law on those, if we subtract the powers, we've got 2 to the power of 3 minus 3, gives us 0, doesn't it? So 2 to the power 0 is 1. And if it had been 7's rather than 2's, or 83's rather than 2's, you'd still get whatever that number is to the power 0, wouldn't you? And the answer would still be 1, doing it this way. So anything to the power 0 is 1. And looking at the second one, applying the second law again, we've got 2 to the 3 minus 4 is 2 to the negative 1. So 2 to the negative 1 must be the same as 1/2. If those 2's had been 7's, you'd have 7 to the negative 1 and 1/7, wouldn't you? And on the third one, we've got 2 to the 2 minus 5 is 2 to the negative 3. So 2 to the negative 3 is 1 divided by 2 to the 3. So conclusions, x to the 0, anything to the power 0 is 1. Anything to the power of negative 1 is 1 over that number. So if you've got a negative power, that means a reciprocal. If we had to find 2/3 to the power of negative 1, then we would need to flip it over, because if you do 1 divided by 2/3, how do you divide by a fraction? Have you had keep, flip, change? You keep the first number as it is, you flip the fraction, and you change the divide to a multiply. So we're doing 1 times 3 over 2. And then finally, x to the minus n, well, we've got a minus 3 here, haven't we? 2 to the minus 3 is the same as 1 over 2 to the 3. So x to the minus n is going to be 1 over x to the n. Right. A few for you to have a go at. I've summarised the laws down here, so you have them to refer to, but of course, in an exam, you won't have that. You will be expected to remember them. And I'm going to give you 5 minutes to have a go at these. So simplify, so get them into their simplest index form, and then evaluate them. So work out what that is as an ordinary number, which might be a fraction. Okay, I'm just going to mute myself and hide my video for a couple of minutes while you have a go at that. Feel free to type your answers into the chat box, and I will come back in a minute or two. Okay, I know I haven't given you long enough to do all of them, but you can always come back and do them on the replay. Let's just quickly run through the answers that you should have got, and then I will go through them in detail on the whiteboard afterwards. So first one then. If we add the powers, we get 2 to the 4, which is 16. Number 2, subtract the powers, 3 squared is 9. Number 3, 64. Number 4 is 1/9. Number 5 is 3/5 to the -2, which is 5/3 squared. Remember I said the negative power means a reciprocal, so that's 25/9. And then 6 is 32, 7 is 1/4, and 8 is 9. Let's just go through those on the whiteboard so that you can see the working. And that's on this tab. Here's one I prepared earlier. So for number 1, 2 to the -3 plus 7, because we're multiplying, so we add the powers. So that's 2 to the power 4, which is 16. Number 2, we're dividing, so we subtract the powers. Number 3, we're doing a power of a power. It's the same one we did before, isn't it? It's 2 to the power of 2 times 3, which is 2 to the power of 6. But we didn't actually work out that bit, did we? We did work out that 2 to the 5 was 32, though. So 2 to the power 6 must be 64. Number 4, 3 to the -2 is 1/3 squared. Remember, negative power means a reciprocal. That's 1/, the number. Or if it's a fraction, it's that fraction flipped over. And 1/3 squared is, of course, 1/9. Number 5, 3/5 to the -2. Well, that's 1/3/5 squared, which is 1/3 squared over 5 squared, which is 1/9/25. And how do you divide by a fraction? Keep, flip, change. So it's just 25/9. So that one's a bit trickier, isn't it? Number 6, careful here. We're dividing, so we need to subtract the powers, but we're subtracting a negative power. So it's 2 to the 3 minus -2, which of course gives you 2 to the power 5, which is 32. And for number 7, getting more complicated, 2 to the 3 times -2 times 2 to the 4. So that's 2 to the -6 times 2 to the 4, which is 2 to the, add the powers, -6 plus 4, gives you 2 to the -2, which is 1/2 squared, which is 1/4. And finally, number 8, 3 to the -2 times 2 divided by 3 to the 3 times -2 equals 3 to the -4 divided by 3 to the -6. So we subtract the powers. So we've got 3 to the -4 minus -6. And of course, minus negative is the same as plus. So that is 3 to the +2, which of course is 9. Okay, back to the PowerPoint then. And moving on, And now let's look at fractional indices. I'd like you to start by using the laws of indices to simplify these expressions. If you want to type them into the chat box, you can do. It helps me to see when you're ready to move on to the next bit. Okay, so for the first one, we're multiplying, so we add the powers. So we've got x to the power of a half plus a half, which is just x to the power 1, isn't it? And of course, x to the power 1 is just x. Same with this one. We multiply the powers, and we've got 2 times a half, again, x to the power 1, which is x. And the same again for the third one. So, how else could you write x to the power of a half? What do you multiply by itself to get x? Or what do you do to x squared to get x? Or what do you have that you can square to get x? What must that x to the power of half be? I hope you spotted, not the reciprocal. What do you times by itself to get a number? If x was 9, what would x to the half be? If x was 16, what would x to the half be? Number that you times by itself to get that number, it's the square root of x. So x to the power of half is the square root of x. What do you think x to the power of a third would be? Well, if we did the same thing here, we'd need to multiply 3 of them together to get x, wouldn't we? So x to the power of a third is the cube root of x. So the rule is x to the power of 1 over n is the nth root of x. Generally, you'll only be dealing with square roots and cube roots, but you never know. You could have a 4th or a 5th root now and then. So how else could you write x to the power of negative a half? A bit difficult to do in the chat box. And how else could you write x to the power of 3 over 2? I'll think about it for a minute and I'll tell you the answers. You can try and write it into the chat box if you like, but it's a bit tricky. You can get the root sign from that character map though, if you're on a Windows computer. Okay, so x to the minus a half. That's right, Kishan, good. The minus means it goes on the bottom of the fraction. It's 1 over. And the half means a square root. So it's 1 over x to the power of half, which is 1 over the square root of x. And then we've got x to the 3 over 2. Well, the over 2 bit means square root. But we've got 3 lots of a half there, haven't we? So you could think of it as being either x cubed to the power of a half, x to the 3 times a half, or x to the half times 3. Either way, it's a square root and it's cubed. It doesn't matter whether you do the rooting or the cubing first. It will give you the same result either way. So you can have either x cubed square rooted or square root of x all cubed. Both the same thing. It doesn't matter which way around you do it. Okay. Now finish off. Some for you to have a go at. Again, I'll mute and turn my camera off for a minute or two and let you have a go at a few of these. I probably won't give you time to do the whole lot yourselves, but you can always come back and listen to the replay and do them then instead, if you don't get through them all now. So I'll be back in a minute or two. I've just gone into the bit paper and you can still see them on the screen there. Okay, so let's have a go through these answers. So for number 1, 9 to the power of half is the square root of 9, which is simply 3. Number 2, 4 to the power of negative a half. Negative means bottom of the fraction. So that's 1 over 4 to the power of half, which is 1 over the square root of 4, which of course is 1 over 2. And if you think about it, if you do a half times a half, you are going to get a quarter, aren't you? Number 3, 16 to the 3 over 2. Well, the over 2 means the square root, and the 3 is cubed. It's easier to root the 16 and then cube it than it is to cube it and then root it, but it will give you the same answer either way. So root 16 is, of course, 4, and we know that 4 cubed is 64. For number 4, 27 to the minus 2/3. Negative power means bottom of the fraction. And 2/3, well, the 3 on the bottom of the fraction means cube root. And then the 2 means square it. Again, doesn't matter whether the squared is inside or outside the cube root sign, but it's easier to cube root 27 and then square it than to square it and then cube root it. So we'll do it this way. So that is 1 over cube root of 27 is, of course, 3, because 3 times 3 times 3 is 27. That's 3 squared. So we've got 1 over 9. And the last one, 4/9 to the power of negative 3 over 2. Now remember, negative power means a reciprocal. So that's 1 divided by 4/9, which is 9/4. So we've got 9/4 to the positive 3 over 2. The over 2 means square root. So it's square root of 9 over 4, and then we cube it. And of course, we do the same thing to both the numerator and the denominator. So it's root 9 cubed over root 4 cubed. So that is 3 cubed over 2 cubed, which is 27 over 2 cubed is 8. So well done if you got those right, or if you got most of them right. And I hope you've spotted where you went wrong if you went wrong. Okay, back to the PowerPoint then. So that's the end of the lesson on indices. I hope you found it helpful. Oh yeah, I do quickly reveal the answers here, but we've been through them already, so let's just skip over those. So back to the what skills do I need for A-level maths? That's indices covered, but you can see there's still quite a lot that you need to get to grips with. So what about the rest of it? Well, there's plenty of online resources available that are free, but there's an awful lot of sifting through to identify what's useful and what isn't there? There are courses available online that you can get for this, but most of them will do it over maybe 8 or 10 hours, and they'll only cover a few key sections. They won't be as comprehensive as covering everything on here. So this is where my Flying Start to A-level Maths course comes in. Of course, you had to get a sales pitch, didn't you? But I'm not going to spend half an hour telling you, oh, what a wonderful bargain you're getting. We've only got another 5 minutes to go, so I won't keep you much longer. So this course is the most comprehensive one that I know of. So what you get on it, I've told you I'm qualified, experienced. I've already done that bit. The content of the course, it doesn't matter which GCSE exam board you did, which A-level exam board you're doing, it's relevant to all of them. And it gives comprehensive coverage of the bits of the GCSE that you are going to need. Now, you've got an idea of my teaching style now, so I hope you liked it. And there's lots and lots of recorded videos that give you a similar sort of approach. But you can pause the video rather than thinking, oh, she's going to come back and go through the answers in a minute. You can pause the video and go through them at your own speed. There are over 10 hours of lessons recorded with loads of practice opportunities built in. So that lesson that I just did with you, that was maybe, it took us maybe half an hour, 40 minutes. On the video, that would maybe be about 15 minutes because I don't wait for a minute or two for you to attempt stuff. I just say, pause the video, come back when you're ready to carry on. So the actual study time is probably at least twice as long for most people, depending on how comfortable you are with the material already. For every lesson, there's also a worksheet of additional practice questions with full detailed work solutions. There's a free Facebook group, which some of you might already be members of, where you can get help with anything you're still struggling with. At the end, you can download a certificate. I also give you links to other places to go if there are some bits where you feel, oh, I could still do with a bit more practice on that. No quibble money back guarantee for first 2 weeks after you sign up. If for any reason you're not satisfied, I will give you a full refund, no questions asked. Well, except how could I make it better sort of question. And the subscription doesn't expire. So if you need to come back to it when you're halfway through the second year of A-level, that's fine, you can do that. You'll still have access. Now the course comes in 3 flavours. There's the self-paced silver flavour, which is everything you've just seen on the last slide. You go through it at your own pace, and that is available all year round. Then we've got the guided gold, which is the one that's just about to start. So this is a 10-week programme. It's starting on the 7th of June, running until middle of August. You get everything in the silver package, and you get a live tutorial each week where I'll answer any questions on the previous week's work, do a general recap, set the work for the following week. And that's ideal for anyone who needs a bit of help to stay on track, because I know if you sign up to an online course and you're just left to your own devices, it's very hard to keep your momentum going, isn't it? But with this one, you've got this live tutorial each week, so you can come along to that and get your questions asked. And hopefully that will give you everything you need, but you've also got the Facebook group where you can ask for help if you need it. And then we've got Personal Platinum, which is similar to the Guided Gold, but it's individual, it's one-to-one. So it's the same 10-week program, but we'll tweak it to suit you personally. It doesn't have to be started in early June. You can do it any time, subject to availability. And you get a weekly half-hour one-to-one tutorial with me. Of course, because I only have a limited amount of time, that is very limited availability on that one. So looking at the Guided Gold one, as I said, it starts on the 7th of June, ends on the 16th of August. And the live sessions are going to be at 7:30 every Monday, but they will be recorded and I will put them on the online course so you can go back and look at them anytime, so you can catch up, and they'll be left there until at least a month after the end of the course. Now, this is where the price bit comes in. This is where your typical internet marketer is going to say, this course is normally £697 and you get this extra and you get that extra, and this is worth another £200 and this is worth another £300. I'm not going to give you any of that rubbish. I don't think you're that stupid to believe that. Normal price is just £100, which is a great deal in itself for a 10-week course. If you enroll by the 6th of June, it's on special offer at only £70. And if you enroll by Monday night, that's tomorrow night, the 31st of May, and you use the code GOLDWEB21, you can get it for just £50. Okay, so it's at mathscourses.co.uk/courses/FSAM-gold. I'll just show you the web page. So this is the collections page, which tells you about the 3 different versions. And then if we go to the Guided Gold page, as we wait for it to load, you can click Add to Basket. And when you get to the checkout stage, it will ask you for the code, and that's where you put your code in and get that additional £20 discount. So that's just a repeat of the summary we've just gone through. Does anybody have any questions? If you'd like to type them into the chat box, you're very welcome to do so. So any questions that I haven't already answered or that you missed the answers to? No, nobody got any questions? Oh, hang on. No, it won't cover the whole A-level content. It's just the aspects of GCSE that you need to be fully up to speed with so that you can cope well with the additional content that you learn at AS and A-level. It is not an A-level course, it's a preparing for A-level. Do I cover pure maths, statistics and mechanics in normal A-level maths? In one-to-one tuition, I do. If you come to me as a tutee and you're doing A-level, yes. But in this course, I cover everything that was on the what topics do I need to know from GCSE. So all the GCSE stuff, right up to the grade 9 stuff, including some of the stuff that you've done in science rather than maths for mechanics. And all of that is covered in this course. What about in a school or normal course? I'm not quite sure what you mean there. Can you clarify a little bit on that? So the standard A-level includes all those topics, but it builds on them. So it takes them beyond what you've done at GCSE, but those are the topics that you need. Yes, in school, they will cover all these 3 parts in the 2 years. My flying start to A-level maths course is literally about the start of the course. It's about making sure that you're ready to hit the ground running and cope with what they throw at you on the course. because it is quite a tough course. Nobody will, or very few people will tell you that A-level maths is easy. Okay, so I hope that's answered everybody's questions. And I hope you found this helpful. I hope you found the lesson helpful particularly. I do like to give good value for money, especially when you're not paying any. And I hope that at least some of you will want to sign up and join the course. Thank you very much. And I hope to see you in a week's time.